Hi, my name is Brendan Barrow from T08. Today, I want to represent about data representation and coding scheme. First of all, what is data representation? Data representation in computer, it receives data also as input is recognized by using combination of binary digit 0, 1. The 0 is represent off while 1 is represent on. There are two ways to represent data in computers, which is binary digit, also bit, and byte. Bit. What is bit? A binary digit. The smallest unit of data on a computer can process. Represent an electric state on or off. Bit 1 represent on, bit 0 represent off, while byte, which is 8 bits that are grouped together as a unit, provide enough different combination of zeros and 1 to represent 256 characters. Represent a character such as digit, letter, punctuation mark, or any symbol in computer. The difference in bit and byte is the smallest unit of data that computer can process, while a byte is and 8 bits are grouped together as a unit. How a letter is converted to binary form and back. Let's say example keyboard. The user presses the capital letter, let's say D, on the keyboard. Then an electric signal for capital letter D is sent to the system unit. The signal for capital letter D is converted to its binary code and is stored in memory for processing. After processing, the binary code for the capital letter D is converted to an image and displayed on the monitor. Okay, character. A number, a letter, punctuation mark, and other symbol that can also represent as character. Let's say we have a number system, a set of numeral for representing numbers. The common number system, which is decimal, which is base 10, binary, base 2, and hexadecimal, which is base 16. Decimal numbers, which is a positional system of enumeration that uses decimal digits and a base of 10. Familiar uses in everyday life, and decimal number consists of 0 to 9. Example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. On to the next step, which is binary. What is a binary? A method of representing number that has 2 as its base and uses only the digits 0 and 1. Bits 0 and 1 are joined together to form binary numbers. Example, 1010 base 2 or 0011 base 2. On to our last number system, which is hexadecimal, a method of representing numbers that has 16 as its base and uses 16 symbols to represent values. For example, 0 until 9 and A and from A until F. Advantage of using hexadecimal is it can represent binary values in a more compact and readable form. And the conversion between the binary and the hexadecimal is very efficient. For example, 3C1E or 9B4, and after that we need to put base 16. Okay, on to the next topic, which is information about coding scheme. There are three types of coding scheme, which is ASC, 11, AEBC, DIC, and Unicode. The ASCII is using 8 bits to represent a character, can represent 256 characters, and primarily used on PC and server. The second one is EBCDIC, use 8 bits to represent a character, can represent 256 characters, and primarily used on mainframe and high-end servers. Unicode, use 16 bits to represent a character, capable to represent 65,536 characters, implemented on in several OS, Windows, Mac OS, and Linux. For example, ASCII bytes. If you were look at files as a computer, look at it, you will find that each byte contains not a letter, but a number. The number is the ASCII code corresponding to the character. So on this, the number for the file looks like this: 4 and 7, FOUR space AND space SEVN. What is Unicode? Unicode is a worldwide character encoding standard. The main objective is to enable a single unique character set that is capable of supporting all characters from all scripts, as well as symbols that are commonly utilized for computer processing throughout the globe. Use 16 bits to represent a character, capable to represent 65,536 characters, which is 2 by the power of 16. Um, how how to calculate the total number of bits and bytes? Let's just say the total correct ASCII EBCD Unicode. Let's say a total character is 17 for ASCII and EBCDIC, but Unicode has 16 characters. Okay, the space between ASCII, EBCDIC, and Unicode are all the same, which is 2. And the total of the total character and space between characters are 19 for ASCII and EBCDIC, but Unicode for total is 18. And the bits for ASCII and EBCDIC is 152 bits, which is 19 times 8. And while Unicode, the bits are 288 bits, which is 18 times 16. Byte, on the other hand, is 19 bytes to ASCII and EBCDIC, which is 152 divided by 8. And for Unicode, which is 36 bytes, is 288 divided by 8.